Russia is reportedly intensifying its efforts to develop the PAK-DA stealth bomber by repurposing and adapting advanced technologies originally created for the Su-57 Felon fifth-generation fighter jet. This strategic recycling of components marks a pivotal shift in the country's aerospace development philosophy, combining innovation with pragmatism in the face of financial strain, sanctions, and logistical hurdles. The decision to use Su-57 systems in the PAK-DA project reveals how Moscow is leveraging its limited but sophisticated technology base to accelerate one of its most secretive and ambitious defense programs in decades. The PAK-DA, Prospective Aviation Complex for Long-Range Aviation, has been under development by the Tupolev Design Bureau, Russia's legendary bomber manufacturer responsible for the Tu-95, Tu-22M, and Tu-160 series. Unlike its predecessors, which relied on speed and altitude for survivability, the PAK-DA is expected to embrace a flying wing configuration, a design emphasizing stealth, reduced radar signature, and high fuel efficiency for intercontinental missions. Early concept images and leaked reports suggest a smooth, radar-deflecting airframe with minimal protrusions and internal weapon bays capable of housing a diverse range of nuclear and conventional munitions. According to Russian defense insiders, engineers have been transferring a number of technologies from the Su-57 program into the PAK-DA's framework. These include radar-absorbent composite materials, sensor fusion systems, and multifunctional integrated avionics that enable pilots to manage multiple threat environments simultaneously. The Su-57's N036 Byelka AESA radar system, capable of detecting airborne and ground targets at long ranges, is believed to be reconfigured for the bomber, giving the PAK-DA enhanced situational awareness despite its stealth role. Additionally, the Su-57's electronic warfare suite, data link systems, and mission computers are expected to be adapted to coordinate seamlessly with Russia's growing network of unmanned aerial vehicles and hypersonic weapon platforms. Beyond electronics, Russia is also reusing stealth coating technology from the Su-57. This radar-absorbent paint and material composition are being modified to handle the extreme heat and stress endured during long-duration flights, an engineering challenge significantly different from that of a short-range fighter. Specialists from the Kazan aviation plant, where the PAK-DA is rumored to be under assembly, have been testing upgraded composites to ensure they maintain stealth performance across varying temperatures and conditions. The reuse of Su-57 technology is not merely a cost-saving measure. It represents an effort to standardize Russia's stealth ecosystem. By ensuring compatibility between the country's stealth fighter and bomber fleets, the Russian Air Force aims to simplify maintenance, logistics, and pilot training over the coming decades. The move also allows the PAK-DA to incorporate proven systems rather than untested experimental designs, reducing development risk. However, the decision also exposes ongoing challenges. The Su-57 program itself suffered numerous setbacks, including production delays, funding shortages, and difficulties producing next-generation ISDLI-30 engines. With only a handful of Su-57s currently in active service, the fighter remains a limited fleet rather than a mass-produced weapon system. Critics argue that transferring unfinished or immature technology from the Su-57 could introduce additional complications into the PAK-DA's already complex development process. Still, Russian defense officials appear confident that the lessons learned from the fighter's production will translate into a smoother path for the bomber. Reports from Russian state media indicate that the first full-scale PAK-DA prototype is under construction and could be ready for static testing within the next few years. Flight testing may begin around 2028 or 2029, followed by limited production in the early 2030s. Once operational, the PAK-DA is expected to replace aging Tu-95 MS Bear and Tu-160 Blackjack bombers, forming the cornerstone of Russia's long-range strike capability. It will likely be capable of deploying Kh-102 nuclear cruise missiles, hypersonic weapons, and precision-guided bombs, giving it both strategic and tactical flexibility. Defense analysts believe that the PAK-DA will play a crucial role in Russia's nuclear triad modernization program. Alongside submarine-launched ballistic missiles and intercontinental ballistic missiles, the bomber represents the air leg of Russia's deterrent strategy, one that emphasizes survivability, range, and stealth. The bomber's low observable profile could enable it to operate deep within NATO-controlled airspace, providing a new layer of unpredictability in global deterrence dynamics. The decision to merge Su-57 and PAK-DA technologies also mirrors trends in Western defense industries, where shared technology platforms help reduce costs and standardize upgrades. Just as the United States relies on the F-35's modular avionics to support multiple variants, Russia's integration of Su-57 systems into the PAK-DA represents a step toward multi-platform technological convergence. This approach could streamline future aircraft designs, potentially benefiting other classified Russian projects such as unmanned stealth drones and electronic warfare aircraft. Despite these advantages, experts remain cautious. Russia's aerospace industry has been strained by sanctions that limit access to advanced microelectronics and precision manufacturing tools. Replacing imported components with domestically produced alternatives has proven slow and expensive. Furthermore, the financial burden of maintaining multiple high-profile projects, including the Su-57, PAK-DA, S-70 Okhotnik drone, and modernized Tu-160M2, has stretched defense budgets thin. Yet, the Kremlin continues to prioritize strategic bomber development as a cornerstone of its national defense and prestige. If the PAK-DA successfully incorporates Su-57 technology and enters service within the next decade, it will mark a significant leap forward in Russia's ability to project power globally. The combination of stealth, endurance, and multi-role adaptability could give Moscow a credible answer to Western stealth bombers and reinforce its long-term deterrence posture. In many ways, the recycling of Su-57 components is more than an engineering choice. It is a reflection of Russia's broader strategic philosophy: to adapt, economize, and innovate under constraint, turning existing assets into instruments of next-generation warfare.